Good morning, class. Sorry for being late. The faster I move, it seems like everything around me moves even faster. Never mind. Today we're gonna cover statics. More specifically, it's gonna be torque. Torque is the tendency of a force to rotate about a fulcrum. It is the cross product of the vector by which the force application point is offset relative to the fixed suspension point and the force vector. Its magnitude depends on the force applied, the length of the lever arm connecting the axis to the point of force application, and the angle between force vector and the lever arm. Understand?
No.
Okay, let's watch the experiment. We will demonstrate torque by performing an experiment. The engineering term for torque is moment. It is a principle that you likely have an intuitive understanding of, but didn't know there was a scientific term for. It's defined as the measurement of how much a force acting on an object causes that object to rotate. It's represented with the Greek letter tau, and it is the cross product between the distance vector r and the force vector F. The distance vector is the distance from the pivot point and the point where the force is applied. Theta is the angle between R and F. Now you understand? Okay, let me try one more thing. Let me show you. Here's the door. The hinge of the door is my pivot point. The entire door is a moment arm in the reference to the pivot point. The closer I push to the pivot point, the more force it is required to open the door. As I move farther from the hinge, or I increase the moment arm, the less force is required to open the door. And finally, as I move even farther from the hinge, even less force is required to open the door. You see? Now understand?
Oh.
All right, class dismissed.